Hello, welcome to the Advanced Modeling Tools lecture. I hope you all had a wonderful weekend. But let's get started. Okay, so first let's talk about connecting meshes. One of the really cool tool that you could use is the target weld tool. So if you ever had like a hole in your mesh, or maybe you're combining two meshes, like for example in the Fox Lab when you had combined the legs to the body, you would use the merge the center tool to sort of be able to combine the vertices together. Another method to do this is the target weld tool, which while the merge the center tool takes the average of the two positions, the target weld tool basically pulls one vertex or one edge to the other, and then sort of like it welds them together essentially like that. Very useful for filling holes or connecting meshes. Another thing that's super useful, I personally love this tool, is the bridge tool. You basically are able to get two disconnected edge loops together, or edges, and you can create faces that connect them. So you basically bridge the two edges together, and then you can adjust divisions to see, sort of like in this picture here, how there's a bunch of divisions in between the bridge tool. Very useful for filling holes, very useful for connecting different meshes. Next, let's talk about deformers. Deformers are very useful because they allow you to modify a mesh without having to necessarily manually edit the geometry of it. And there's a lot of different deformers, and they're pretty useful for modeling and rigging purposes. Here are some examples of some. Some particular useful ones are under the deform nonlinear tab, such as the bend deformer, squash and stretch, flare, and sine wave. Sine waves is useful for making like ripples in water, that type of thing. Bend deformers, very nice, to be able to use to sort of like bend objects over. So here's another example of the bend deformer, where you can basically take a mesh, apply the deformer, and it basically bends it along a curve. Here's the flare deformer. The flare deformer basically takes a mesh and it like flares it upwards to make the top part really big and the bottom part really big while it like shrinks the middle. This is the squash deformer. Essentially, you can change the squash deformer like how much is squashing or not. So if you ever done the bouncing ball animation lab, well, this is how the squashing was done. Now you know how the squashing was done. Yeah, so you can set like a low bound or a high bound and like the amount of squash that it's going to be doing. This is the lattice deformer. The lattice deformer is especially useful for changing organic shapes like clay, or you just need to stretch things around. You basically create this lattice cube thing, this array of cubes, that basically define the deformation points, and then you can adjust the deformation points like this to sort of like stretch out an object. Additionally, you can combine the lattice deformer with joints and rigs to sort of have like certain rigs affect the lattice deformer, which then affects the deformation of the entire object. As seen here, this is a skirt rig that I did for Melchan mascot. Um, but yeah, so it uses the joints to deform the lattice, which deforms the skirts. Deformations are also non-destructive, which means that they're not finalized. Basically, if I create a deformer, I can still move the mesh around, I can still move the deformer around, and nothing gets changed. But also conversely, that means that if I delete the deformer, the geometry will return to normal because it's non-destructive. If I want to apply the deformation, what I would do is I would select the object and then I delete history. And that will apply everything so that the deformer no longer affects the geometry and it's sort of like baked into the geometry. So I would do that at the end when I'm done with deformations. Otherwise, I would just leave the deformations alone, just so I can edit it in the future, in case like I need to. But also, do make sure to delete your history once you're done. Okay, next let's talk about using NURBS. So nerves by definition is non-uniform rational B-splines, which I honestly don't need to remember the name of, but they're essentially curves or objects that aren't polygons. They're basically like perfectly smooth surfaces in that sense. There's this curve shelf they can use to create a lot of curves. One particular useful one is the Sp curve tool, which basically you can define a bunch of points and then you can create curves based on that. Some useful things that you can do with curves. I think you've used curves before too, with rigging when you're making your controllers. Those are NURBs. But you can actually use them for a lot more than just like, oh, controllers for rigs. One thing you can do is extrude along a curve. So given like a perfectly smooth curve like this one right here, you can select it, you can extrude it, and then you can create a bunch of divisions like this. And then this is a really easy way to create really smooth curves. With a polygon mesh. Alternatively, there's a newer way to do this called the sweep mesh. I love the sweep mesh. Essentially, you click a curve, you click the sweep mesh button, and bam, it generates a mesh that sweeps across the entire curve. And then there's a bunch of settings here, like the precision. You can see how precise it is to the curve. You can also use custom meshes as well. So right here, I have a mesh that I made, and then I'm extruding that along this sweep mesh like this. And you can see how like this matches over here. And then you can also twist and taper and that type of thing. Over here, you can use the distribute tool to create a bunch of different like instances of it around the curve, and then you can use the twist to sort of like twist it around and make a little cable. So sweep mesh is very, very good for cables, hair, tubes, any like streaks that you're doing, tentacles, even things like picture frames could be useful. Next is lofting and revolving. So let's say you have a curve, you can basically loft, basically do like a 3D rotation around it, like this. If you've ever taken calculus before, this is the same as, what's it called in calculus, where you have a function and you need to like do a rotation around the function. It's basically that. But essentially, lofting allows you to take a curve and just sweep it around and like revolve it around the surface, and then you basically get a mesh like this. One important thing to know is that when doing these actually create NURB primitives. So this mesh right here is a NURB, not a polygon. And NURBs don't actually render in the rendered scene, so you must convert them back into a polygon object by doing NURBs convert to polygon. Yeah. So advantages and notes on using curves and NURBs. Essentially, you're creating your own deformer. After you create your polygon, you can edit the overall shape, so it's non-destructive until you delete your history and you convert back to polygons. Basically, if you change the control points, then the mesh also changes. But yeah, it's very important that NURB objects do not render, so you must convert your objects back into a polygon. Now let's cover some miscellaneous tools that could be useful. One thing is Boolean operations. Basically, you take one object and you take another object, and you can use the Boolean difference to cut one out of the other. So for example, I have this gear object and this cylinder, and I basically intersect them, use the Boolean operation, and bam, it cuts it out. Very useful for hard surface objects. For example, if you're making, say, like a spaceship, or if you're making like, I don't know, like a robot or something. Very useful to be able to cut these objects out. But one thing is, depending on the meshes that you're using, they can create a lot of n-gons. So I would recommend only using these for hard surface tools. Additionally, make sure to delete history because Boolean operations create a lot of temporary objects. And so you need to delete history to sort of apply the Boolean operation. Next is Paint Effects. Paint Effects is a pretty old tool in Maya, but it is still pretty useful because it basically allows you to get a canvas and like paintbrush with like 3D objects. So there's this massive prefab, like a massive like content browser, for like prefabs for the paint effects, and there's a lot of different presets you can do. For example, this one right here has the grasses presets, and you click it and then you just draw, and then it automatically creates like trees or like vines, and then you can also animate these going up as well. Additionally, Paint Effects does have um a feature that allows you to very rudimentarily edit a texture. So instead of having to export it out, you can just manually edit it using Paint Effects. But it's a pretty old tool, so some of the things may not be like as intuitive and that type of thing. Next is duplicate special. Duplicate special is very useful for creating instances of objects. So one important thing is that an instance is not a copy. Instances basically share all attributes that the base mesh also shares. For example, in this object right here, if I select this edge, then it also selects all the instances of it, and any changes I make to this original one um, will basically also affect all of the instances. So here with this duplicate special, I can offset and then create a number of copies, and it basically creates it duplicates the copies with the instance parameter. And you basically it's very useful if you want to create like an array of buildings, or you just have a lot of objects that need to basically be similar but just in different positions, orientations, and scales. Then using instances can be really useful because they're not individual meshes. So if you edit the original one, then all the other ones also equally edit as well. So very, very useful for things like that. Next, let's talk about Mash. So Mash is basically Maya's motion graphics tool. You basically can create a lot of large networks of objects, and there's a bunch of different nodes and stuff that do really cool things. But essentially, it's for motion graphics. But it's also very useful for very rudimentary simulations or just basic procedural distribution. So, for example, you have this random node that basically takes all these instances of objects and then it randomizes the values a bit. We have this color node where you can combine it with the random node to create different colors or like color jitter for different objects. You have the dynamics node, so you can create things like collisions where you have a ball that knocks over a bunch of objects, or you can have things like gravity, things like that. Then you have your time, flights, and audio. So if you want to create like an audio visualizer, that type of thing, can be pretty useful. The flight node, I believe, simulates boids. So if you have a bunch of like flocking simulations of like birds and that type of thing, or like fish, the flight node could be very useful. Yeah. So now we'll move on to a demo for Mesh. Okay, so here we are in Maya. Let's go and cover some of the stuff real quick that we covered in lecture. Um, so first is the target weld tool. So let's say I have an object that looks kind of like this. One method to sort of like fix this hole or to connect these objects is to select these two vertices and merge the center. But you notice how when you use the merge the center, it merges to the center. So then you get this really awkward angle here. Instead, what we should use is the target weld tool, which is this tool right here. You click this, then you click and hold an object and then select it to the other, and you can see basically where it's supposed to connect to. And whoops, I selected the wrong one. But let's say you take the target weld tool, select the right vertice, and you move it over. You see how it basically moves this vertice over to this one and then merges it together. So using these like this, bam, I can now fix this hole. Um, Another way you can do this is to use the edges instead. So instead of being in vertex mode, I can go to edge mode, and then I select this. Bam, I can do that. I select this like that, and bam, that fixes the hole. So target weld tool, very useful for fixing holes and connecting meshes, in which you want the vertices with the edges to stay in the same positions. And one thing they can do that merge vertices can't is like you can weld edges, right? You can't do that with the merge merge the center tool. Okay, next let's showcase the bridge tool. So let's say I delete this right here, and I want to connect these two together. So I would select this and just select this. Ooh, I don't select them. Do this. Here we go. And then let's do the bridge tool, which is this one right here. Looks like a little bridge. If I select it, both sides of the edges must be a closed loop. Ooh, I have a quick. Nope. It seems like I just forgot to merge some vertices when I created the test object clear. But Yeah, let's do this again. There we go. And then we click the bridge tool, and bam, it basically bridges these two edges together. But if I didn't do with the entire edge loop, I did like this is what the bridge tool would do, essentially. Okay, so next let's talk about deformers. So let's say I have this cylinder over here. And let's just give this a bit more subdivisions. Heights over here. So let's say I wanted this to like curve over, right? What I would do with the deformers is that I would go to the deform tab, and there's so many deformers here. I encourage you to actually like check some of these out because they're kind of interesting. But if I go to nonlinear, the bend deformer, I basically created a deformer handle, which you can't really see because it's hidden by the mesh. But if I move it over, this is what the deformer handle looks like. Let's move back into the center. And then say I were to take, I select this over here in the attribute editor, I can basically change the curvature. You can see how this deforms the object while also um, creating this curve right here. So this high bound and low bound basically says like how far I want to affect it. So the more like this, like it deforms around this entire area, and then the high bound as well. So if it's not in the if it's not in the bounds, then it doesn't deform. Alternatively, if I click P, I can just edit it like this. Drag these up and down. Very useful. This is the bend deformer. Alternatively, what I could do is do like a sine deformer, right? So if I deform non-linear, and like a sine deformer like this, I can change the amplitude. And then I could rotate this deformer so it's like this over on its side. You can see how it's deforming this object like this. These are the control points. So these are deformers, very useful. And notice here how if I delete the deformer, the mesh goes back to normal, because if you want to apply the deformation, what you have to do is delete history, then the deformer goes away, and then this gets baked onto the mesh. So just make sure to delete history after you deform. Oh, I guess I could also showcase the squash deformer. So if I go to deform here, and I believe it is um, nonlinear squash right here. So this is the squash deformer, and you could basically move it up and down like this, change the squash a bit. Right here, if I move this to the bottom, then it squashes at the bottom like that. There's a bunch of these settings you can mess around with. But this is how you create the bouncing ball. Um, and yeah, so very useful deformers, very useful for modeling, very useful for rigging. Check some of these out; they're pretty useful. Next, let's talk about NURBS and the sweep mesh. So usually when creating NURBS, you want to be in an orthographic view like this. And if you go to the curves, there is the EP curve tool. There's a bunch of all these other curve tools as well if you want to mess with them, like do other types of curves. Essentially, the EP curve tool is I create a bunch of points and then it makes a curve like that. I click enter and then it creates the curve. And here I can this. If I ever want to edit the points, I can go to curve points like that, or uh, edit point like that, and I can move these around this just to get a more dynamic shape like that. And then let's showcase the sweep mesh, right? So if I go to poly modeling here, and then I click the sweep mesh button, bam, it just works, right? It creates a sweep mesh. You can see here how it's not very like good because there's a lot of like jagged edges and that type of thing. It's not like fully conforming to the mesh. That's because in this interpolation area over here, it's only at 75% accuracy. If I increase this all the way up to 100, it follows the mesh perfectly. And then click optimize as well, just so I have less like these straight edges don't have that many these what's it called edge loops initially. I can basically change the scale of it to thinner, and twist it well. Twisting doesn't really show too much unless I have, for example, I activate distribute, and now I have a bunch of different like copies of it like this. And then if I twist it like this, bam, now I just made a cable. I think if I twist it more like 10, ooh, maybe that's too much. Also, twisting isn't very good if you use the optimize. So let me turn that off. Um, and let's increase the twist. Bam. That was kind of more like cables. Um, and yeah, very useful for things like that. You can also do coverage, so it doesn't cover the entire thing. Or like the coverage of the distribution node. So for example, you can see here how um the coverage is low. It only goes like partially around. Otherwise, if you want to go all the way around, you set the coverage to 1. Um, things like that. Taper is very useful. So if you want one end to be like very small, like that, and then the other end to be like, very big, you can taper. Additionally, let me just turn off the distribute and then optimize again without the twist so it doesn't lag my computer. Um, And then additionally, instead of using like a polygon like this, you can also do like you want holes at the end of it. You want to make it be like a rectangle instead. Lines, make it like this, like ribbons. You have arcs that make it kind of like this. You have waves, make it kind of wavy. You also have a custom object. So for example, let's say I have this cube and increase subdivisions a bit and give it a more interesting shape. Like this, I don't know. What you need for this to work is you need border edges. So border edges are basically, you need holes, essentially. So delete this, and then that. So you need holes in this mesh. And then what you would do is over here in the sweep mesh, you would click custom. You change the type to a poly object, and then you select your object. And bam, basically this object now gets like extruded along this curve, and you have this custom object to be your sweep profile. Nice. One really cool thing about this is that if you edit the curve, then you also edit the like it automatically changes the sweep mesh as well. For example, if I edit point on this curve, and then let me just hide the sweep mesh. If I edit the points on the curve, for example, like this, then I move these around and I unhide this. Um, you can see how the sweep mesh now conforms to the new shape as well. So basically, unless you delete history, the curve will always basically affect the sweep mesh like that. Yeah, and then once I delete history, bam, the sweep mesh gets applied. Now it's disconnect. Oops, I did 2 sweep meshes. But yeah, now it's disconnected from the curve and moving. Ooh, delete history in this one. And moving the curve does not affect it anymore. But if I didn't do that, if I didn't delete history, um, and edit the points, you can see how moving the points moves the curve, moves the sweep mesh as well. Nice. Okay. Let's showcase the Boolean difference a bit. So let's say I have this right here, cylinder, and then I create like say I don't know like a gear like this. Um, Essentially, what I could do is if I want to cut one object from the other, select this object at the top here. This is the Boolean difference. There's a bunch of also different ones you can do, like union or intersection and that type of thing. For example, we're just gonna do the difference. If I do this, oops, wrong way around. I think it's like this one. Oh, not like this one. There we go. It basically cuts this object out, and you can see how there's still like this ghost that appears. That's because if I actually move this ghost around, it's non-destructive in the sense that I can move this around and it changes where it cuts. Um, and then once you're done and you're happy with it, basically just delete history and these will go away. Otherwise, if you don't, you get a bunch of these like empty ghost objects in your hierarchy, and it causes a lot of problems. So just delete history when you're done, and bam, now you've cut an object out of another. Paint effects. So talk about that a bit. So paint effects. Basically, if you go to generate, and then you go to the get brush tool like this pops up. And for example, let's say I have like, I don't know, clouds, glass, something maybe like feathers, or where's grass? Grass right here. Let's say I want to like paint some grass. I can basically click this, and then I have this brush. I can just, ooh, look at that. And it just basically creates these. And so there's essentially the way it works is that there's a curve underneath it that that dictates where like the mesh grows. There's a bunch of these options as well. For example, you can change the density of the objects. You can change like the offset from the surface, that type of thing. Kind of useful if there's a preset that you quite like. You just want to be able to draw the polygons. Duplicate special. So let's say I have this object, and I want to create a bunch of instances of this object. So I would go to edit, duplicate special, option box. This is basically what it is. By default, I believe it's copy geometry type, but let's showcase the instancing. So if you select instance, and you can basically set an offset for all these different objects. So let's say I'll do maybe like 1 on the X, 1 on the Y, and then let's rotate 15 degrees on the Z, and then let's slowly make these bigger and bigger, like this. And then let's increase the number of copies, like 20. I click duplicate special, bam. You can see how it did this, right? So basically, the duplicate special options were for every new copy, I will translate it 2 up, and then I will rotate it 15 degrees, and then I'd scale it, right? Um, and this is the duplicate special that happens. And then if I were to say select this face, it selects all those faces, and then it moves them all like that because these are instance copies, right? They share all attributes like this. So for example, if I were to say, I don't know, insert an edge loop, and then I were to take this face, extrude it out, take this face, extrude this out, like rotate it. You can see how it applies to all these because they're all instances of this original object here. Yeah, so if you have like say a building, duplicate special could be useful to just like create a bunch of these buildings as well. And you don't have to like manually like control D duplicate like that. So duplicate special can be very useful for that type of work. Cool. Next, let's actually talk a bit about Mash. So basically, in order to do Mash, you first need like an object, and then you can basically create a Mash network from this. So if I go to this Mash tab over here, there's this Mash network. By default, if I select an object and create a Mash network, it basically does a distribute node. So the distribute node, essentially, what it does is that it takes in the number of points, and this is basically duplicate special. These are all instances of the base cube object that is now hidden. But this is Mash, and if you look at the Mash tab, there's a bunch of these nodes that you can work with. Some of these are pretty cool, like trails, or like string. Yeah, so there's a bunch of these nodes that you can work with. And over here, this reproduction here has the geometry that I'm reproducing. And this is here is a distribute node. So if I change the number of points, I can change how many are distributed along this distance x over here, like this. There's also a distribution type. So if I do radial, it does it like in a circle. Maybe I can make like a Stargate from this or something. Or for example, say like spherical, and increase the number of points, slowly better approximates like a sphere, things like that. Um, for now, what we're gonna do is we're gonna use Mesh to essentially create a create grass and create like a cobblestone path. Okay, so what we're going to do with Mesh here is we're going to go and essentially create a field of grass with a cobblestone path, all procedurally. So here I have this little like stone rock mesh. It's kind of bad, I know, but it's just for demonstration purposes. And then I also have this plane, which is going to be our floor. So what I'm going to do here is I'm going to go and select this object, and then I'm going to go and create a mesh network. And when I create the mesh network, it automatically creates this distribute node. What I'm going to go and do is over here in the FX tab with mesh, I'm going to go to the mesh editor, which basically brings up here. So this mesh network that I selected has a bunch of these nodes, and I can easily switch between the nodes and turn them on and off like this. What I'm going to do is in this distribute node, instead of being distribution linear, I'm going to change it to distribution mesh. And then I'm going to go and middle click. I'm going to middle click drag the floor into this input mesh. And now you can see how there is rocks that is distributed across this mesh. Is using this mesh as the distribution input essentially. For these purposes, I'm going to go and lower the number of points to 0 because I don't want it to distribute all the way across the entire mesh. What I'm going to do instead is I'm going to go and add a placer node like this. And so now I have this placer node. And if I click this add button, I can essentially just paint on here. And it's a bit hard to see. So I'm going to go and turn shadows button, shadows on. Might be a bit easier to see, guys. Okay, how about okay, I'm going to go and change the color of this plane. So I'm going to just assign it a new material surface. There. There. Now you can see this a lot better. So if we go to this mesh tab over here and there's the placer node over there, I can essentially click this add button. Um there we go. And then I can draw on here and it basically creates like it distributes this wherever I draw, which is very useful. So for example, if I were to say decrease the radius a bit so it's not as big, keep it bigger, and then I can turn on scatter if I want to scatter it around this entire brush. And then what I can do is I can increase brush strength, so maybe I'll do like 15. Oh, not the brush strength, the density. So let's say I were to increase density like this, to like 10. This will basically create 10 of these rocks wherever I wherever I paint, essentially. So let me increase this up a bit. So do a density of like say 20. And then let's actually delete some of these. So that's like eraser. And let's like mark out like a path. So this, maybe it goes out this way, forward up a bit, and then turn right. This. And then I have this path over here. It delete some of these because they're a bit too much there. Maybe my delete radius is high. Bam, like that. Maybe I don't want it over here. Maybe over here like this. Okay. And then after that, what I'm gonna do after I painted the stones and I'm very happy with the path that I did. We're gonna go and randomize it a bit. So right now all these stones are like facing the same direction. What we're gonna do is in this mesh network, we're going to go and add a random node. So, where's the random node? It is random right here. So let's add this random node and it basically randomizes it a bit. Right now we're randomizing the Y position, so let's not do that. We can do that very little. Actually, no, not all. What we want to do is randomize the rotation a bit. So let's randomize to rotate Y value here. So basically, every object is now randomly rotating around the Y-axis. Move this down just a bit. See more of these rocks. And then we can also randomize the scale a bit. So every rock is now slightly different size, just so we can give it a bit of variety here. And if I find the rocks are too big, I can always go and look at the original rock, maybe scale that down a bit, and then notice how it affects all the other rocks as well, because this original one, everything else is like a instance of it. Cool. Um, maybe I need it a bit bigger. And then with the randomize, maybe something like that. Doesn't look too bad. Doesn't look too bad. But you can mess with the randomization to basically like randomize it a bit, just so you give a bit more variety in that sense. Cool. Next, we're gonna do some grass. So now that we have this cobblestone path, let's make some grass. So I'm gonna go and create a very basic grass plane real quick. So let's lower this down to 1. And then create a grass plane. So let me just extrude this up a bit, scale this down, extrude this up a bit. I don't know. Does this look like a blade of grass? Kinda. Kinda. There you go. Blade of grass. Um, there you go. This is my blade of grass. Um, Move these vertices in a bit. Um, and then blade of grass. Maybe it's a bit too big right now. Let me make it a bit smaller. What I'm gonna do is now I'm gonna go and create a new mesh network, right? So I had one network for these rocks. Now I'm gonna go and create a new mesh network for the grass. Before I do that, let me actually just take this object and um edit it just a bit more. What's very important for this is I want to take the pivots of this object and I want this to be at the very bottom. This pivot is basically where the distribution is going to be. I don't want it to be distributed like in the middle of here. I want the bottom of the object to be the bottom of the object. So the um I'll move the pivot down there. And then let me center this in the world coordinates over here. So here, I'll basically center it like this. Yeah, and now it's in the middle of the world. And then what I'm going to do is I'm going to go and create a new mesh network. Bam. Now, same thing with this distribute node. what I'm going to go to do is I'm going to take this distribution type and I'm going to go and change this to mesh. And then I'm going to attach this floor plane again. Now the grass is distributed across this entire plane. And then what I'm gonna do is just gonna increase the number of points. So like let's say 1,000. There we go. I have a bunch of grass all over this place. Maybe 2,000. Great. Now what we're gonna do is we're going to go and change the rotation a bit. So just like before, all of this grass is like all looking at the same location. Actually, let me just apply a material to this grass so you can see it a bit better. So this is the original grass strand. So assign new material, just a random standard surface. Let's give it like a green color. That. And then the grass. Let me hide the original mesh again. Yeah, let's go and add a random node. So randomizing this. I don't want to randomize the position. I just want to randomize the rotation. Y rotation or the Z rotation just a bit. The X rotation just a bit. But it's mostly this Y rotation. Okay, so we don't want this grass to be all over in the middle of this these cobblestone path, right? We want the grass only to be in places that the path isn't. So what we're going to do is we're going to go to this mesh network and we're going to go and add a new node. So this right here is the strength node. Let's add the strength node here. Let's add the strength node here. And in the strength node, let's add a fall off object. So if I right click this, click create, this will create a fall off object. And essentially, if I move this fall off object over here, you can see how this mesh network only appears in this fall off radius over here. So what I could do is if I invert the fall off, it basically appears everywhere but here. Very useful to basically control like how strong you want everything else to be. There's like an inner zone. For example, like you can see how if I move this, it changes the size of the inner zone. What we want to do here actually though is to change this shape over here. Instead of a sphere, not a cube, we want to change this to mesh. And then once we have to change it from into a mesh, we want to go and drag it into the shape in connection right here. So we want to take this object that we made with the rocks right here, and in the strength node, just drag and drop this into the fall off object, which is I go to this fall off object right over here. If I drag this these rocks into the shape in, now I'm using this mesh right here as the fall off for the fall off node. And basically, if I uncheck this, it'll only be in here. And if I invert this, it'll be everywhere else but this mesh. Great. And now changing these inner zones and outer zones, you can mess around with this ramp as well. So maybe I want like a tiny bit of grass in the middle. Like ramp it like this. There we go. And then yeah, now I have this field of grass. And it looks not that bad, not that bad. And obviously I can always tweak it. For example, like if I can turn these like on and off at will. So if I can see what the random node actually does to this, if I can see what the strength node actually does to this. So maybe I want even more points, right? So I can do like 5,000 blades of grass. um and there's also a bunch of different distribution types I can do, or like distribution methods here. So I could distribute along the vertices or maybe the UV space. Um, but essentially, this is how you create field of grass. Okay, that is all for Mesh. Next, let's talk a bit about Bifrost. Okay, so Bifrost Graph, not to be confused with Bifrost Fluids, is basically Maya's visual programming language. Um, you can do a lot of things with this. We actually have a couple labs on Bifrost, but it's very useful for saying doing like procedural modeling, procedural rigging, procedural animation, simulations, VFX. Today we're going to be focusing on procedural modeling. Encourage you to check out this video. I'm not going to play it here, but open up the lecture slides, and this person has like a demo reel of all the stuff he does in Bifrost. Very, very, very cool. What we're going to do is we're going to do a demo of Bifrost and how to create a landscape. Okay, so here we are in Maya. So let's get started with Bifrost. What I'm going to do first is I'm going to go to this FX tab over here, and then I'm going to go to Windows, and then I'm going to go to the Bifrost Graph Editor, and this should pop up here. I already have a workspace set up with, so it just looks nicer on my display. But here I want to do create graph. And this is essentially a Bifrost graph. It's kind of like Hypershade where I can click tab and I can create a bunch of different nodes. But what I'm going to do here is that these things are called compounds. And I'm going to go and create some terrain. If you're a bit confused, it's fine. There is a more in-depth lab video. I believe it's the Bifrost Clouds lab video, also made by yours truly. But that goes a lot more into depth as to what Bifrost is here. If you have any questions, you can always just let me know on Discord and I can help you out. But I'm gonna go through this pretty semi quickly. Yeah. So what I'm going to do first is I'm going to go and create a mesh plane. And then I'm going to go and output this to a terminal. Like this. And this basically just creates a plane, right? I can change the dimensions here, so like the length and the width. So let's just do 20 on the length and width. And actually maybe 25. And then let's increase the subdivisions to like 200, just so we can give this a lot of detail. Turn off the grid so it's not as distracting. Great. So now we have this mesh plane. How do we actually turn this into some sort of terrain or like mountain range? What we're gonna do is we're going to go and take a fractal noise field. So fields are essentially imagine associating every point in space with a number. This is what a scalar field is. And this is basically some type of noise that's going to determine and displace our points. So we can actually visualize this if we do a scalar field scope. What we're going to do is we're going to take this noise field into the scope, which is our diagnostics. And we're going to use this geometry as in like, okay, we want to apply this field on this geometry, and then let's visualize it. So plugging this in here, you can see how there's a bunch of different colors, right? So the red values here are the positive colors, are the positive values of this field, and the blue values are the ones that are near 0. I can also view negative values as well if I go to the color remap and I change this to -1, -1, and then it will also show negative values underneath here as well. But I'm gonna go and just move this back to 0 like this. See all these blue colors as well with the color remap. But essentially, what we're going to do is we're going to go and I'm going to take scope real quick. We have this noise field. We want to basically displace all of these points based on this noise field. So if I take this displace points, very simple. I take this mesh, I put it in here. I take this noise field, I put it into the weights, take these out points, and these are my output points. And you can see how the noise has now displaced points. So what I could do is I could take this fractal noise field and I can adjust the settings of it, right? I can change the number of frequencies it has. I can change the actual frequency of it. So let's say I want some rolling hills. I can do something like this. I can increase or decrease the ratio between all the different frequencies. This. These look kind of decent, kind of decent. But they're also kind of like there's not much control I could do here. What I could do is I can do something called a F curve field, which if I plug this into here, I plug this out into here. This F curve essentially dictates like what happens to this field based on a curve. And you can see here I sort of like cut out all the values here because there's no negative values. What I could do here is if I remap this to -1, -1 like this, there I get the negative values back in. So what I could do is if I want some valleys, and then sort of like smooth out the bottom, I can adjust this so that the bottom values happen more, and then the high values are more flat. So maybe it's like a mesa, right? And adjust this over here like this as well. Make the high values even higher, and then maybe in the middle, I want to go and flatten this out in the middle a bit. Yeah, so maybe there's like this bottom level, then there's this middle level as well. That I can increase the number of frequencies, increase the frequency here, frequency ratio to just give it more detail. But essentially, this is how you can create some really basic terrain with Bifrost. If I want to move the field, I can use a translate field node. So before I do the F curve, plug this in here, here, and then I could translate the field left and right. Like, yeah, I don't like this position. But yeah, this is essentially how you create a some really simple terrain using Bifrost. And it can be very, very powerful, especially if I start adding fields together and then I'm moving them and then I'm multiplying and layering them and have these F curves and things, and like different displacements. You could definitely do some very, very interesting things with this. And remember, this is just a plane, right? And I'm just displacing points. Yeah, that's basically TLDR on Bifrost Graph for uh making these terrain objects. Okay, so this is your homework. You need to go and complete the hard surface modeling lab and also read the node editor lab for your group projects. Make sure you model your props and your environments. Also submit the weekly team progress reports. For attendance, I know you technically don't have class, so you don't have to do this, but it would be very helpful if you want to provide feedback. Keyword is manifold. And yeah, you can go and provide feedback in the attendance form. It would be greatly appreciated. Okay, have a nice day. Bye bye.